equation that tells how many alien civilizations could exist. How scientists use one formula to predict extraterrestrial civilizations. By Physics Explained. Are we alone? It's one of the biggest questions humans have ever asked. But instead of guessing, astronomers actually use an equation to estimate how many intelligent civilizations might be out there. It's called the Drake equation, and even though it looks scientific, it's really just a way to organize our uncertainty. In 1961, astrophysicist Frank Drake wanted a structured way to think about the chances of other civilizations in the Milky Way. So he wrote an equation with 7 factors, each representing a step needed for intelligent life to exist and communicate. This Substack is reader-supported. To receive new posts and support my work, consider becoming a free or paid subscriber. The parts we actually know. The first 3 terms are the easy ones. Astronomers have solid numbers here. How many new stars does the Milky Way produce each year? About 1 to 3. Not controversial. Our galaxy is a star factory, and it's been running for 13 billion years. The pillars of creation in the Eagle Nebula are perhaps the most famous star-forming structures ever imaged. Those towering columns of gas and dust are incubators where new stars are slowly condensing out of the cloud. The James Webb Space Telescope gave us a stunning new look at them in 2022. Those bright red orbs scattered throughout the image are protostars, stars caught in the act of being born. A dense pocket of gas within a pillar reaches a tipping point where gravity overcomes the outward pressure of the surrounding material, collapses inward, and over hundreds of thousands of years grows hot and dense enough for hydrogen fusion to ignite a true star. Along the edges of the pillars, the wavy lines that look like flowing lava are ejections from stars still in the process of forming. Young stars periodically shoot out supersonic jets that tear through the surrounding gas and dust, creating rippling shockwaves with the same wavy patterns a boat leaves cutting through water. These stars are only a few 100,000 years old by cosmic standards, and will continue forming for millions of years to come. Thanks to the Kepler mission, we now know this number is at least 0.7, probably closer to 1.0. Almost every star has planets. That was a guess in 1961. Today it's a fact. The chart shows 4,034 planet candidates discovered by the Kepler mission as of June 2017, plotting each one by how long it takes to orbit its star and how large it is compared to Earth. The dense blue cloud packed into the lower left corner reflects Kepler's detection method, where planets that orbit closely and cross their star frequently were simply easier to spot, meaning the actual number of worlds out there is almost certainly far greater than what is shown. With over 4,000 candidates from just one telescope staring at one small patch of sky, the takeaway is impossible to ignore. Planets are not rare exceptions. They are everywhere. How many planets sit in the habitable zone? Not too hot, not too cold. Current estimates say about 0.2 to 0.5 per system. Not every star gets one, but there are billions of stars, so billions of chances. This chart maps known exoplanet candidates by how much starlight they receive compared to Earth and how hot their host star is, with the shaded regions marking the habitable zone where liquid water could exist on the surface. The conservative zone between the yellow and blue lines is where scientists are most confident, while the optimistic zone stretches further in both directions to include edge cases, much like how Venus and Mars sit just outside our own solar system's sweet spot. Each planet is sized to scale relative to Earth, and names like Gliese 667cc, Proxima Centauri b, and several TRAPPIST. One planets land right in that critical band, making them the most watched targets in the search for life. If you're reading this, you're already my kind of audience. I write here on Substack and post companion videos on YouTube. Subscribing is the easiest way to support the work, and if you're able to pledge, it makes all the difference. The parts where we're guessing. Here's where the equation stops being astronomy and starts being philosophy. We have exactly one example, Earth. And life here showed up almost immediately, within a few 100 million years. That either means life is easy and the universe is teeming with it, or we got extraordinarily lucky. One data point can't tell you which. This is the pale blue dot, one of the most famous photographs ever taken. In 1990, NASA turned the Voyager 1 spacecraft around after it had traveled roughly 3.7 billion miles from Earth and pointed its camera back toward home. capturing our planet as a tiny fraction of a single pixel suspended in a ray of scattered sunlight against the absolute blackness of space. Carl Sagan, who championed taking the photo, wrote that it puts our entire existence in a humbling context. Every human who ever lived, every war ever fought, every civilization ever built, all of it on that one pale blue speck. This is the big filter. Earth had living things for 3.5 billion years before anything bothered to think. Most species that ever lived were perfectly content being bacteria. Intelligence might be a fluke, not a destination. Humans did. Dolphins didn't. There might be brilliant civilizations out there that never felt the need to broadcast. This is the term that changes everything. 100 years? 1,000,000? If civilizations tend to destroy themselves shortly after discovering nuclear physics, and we don't yet know that they don't, then the galaxy could be full of dead signals and empty ruins. If they last millions of years, we should have neighbors everywhere. So how many civilizations are out there? Plug in pessimistic values, and you get about 20 civilizations in the entire Milky Way. Plug in optimistic values, and you get 50 million. That range, from 20 to 50 million, should bother you. Same equation, wildly different answers. The first 3 terms are basically solved. The last 4? We're not even close. The Drake equation doesn't tell you how many civilizations are out there. It tells you what we'd need to know to find out, and how little of that we actually have. If you're reading this, you're already my kind of audience. I write here on Substack and post companion videos on YouTube. Subscribing is the easiest way to support the work, and if you're able to pledge, it makes all the difference.